All right, so today we're going to start out with the tree diagram. This says a tree diagram can be used to find the possible outcomes in a sample space and to find probabilities of combined events in an experiment. The key features of the diagram are as follows. The probability for events are written on the branches. So the probability of events are written on the branches. I think most people should be familiar with a tree diagram, because I think the tree diagram, you should have done that from OddMath. All right. So this says the probability of an outcome in the sample space is the product of all possibilities along the path that represents the outcome on the diagram. So, for example, what they're saying here is that the product of the probability of head would be a half times a half times a half. That's what they're saying. Times a half. All right. So if I want to follow the probability of to get the probability of head, it would be the probability of every path getting to the head. So it's the probability here multiplied by the probability here multiplied by the probability here. All right. So the probability of head would be a half times a half times a half. What else? To find the probability of one outcome or another, we add their probabilities. Here is a tree diagram for tossing a fair coin 3 times. So one coin is tossed 3 times, and this is the tree diagram that represents that. So here you will have the first toss. This would be the first toss. And in the first toss, you could have either a head or a tail. The probability of a head is a half, and the probability of a tail is a half. This is the second toss. All right, and then the possibilities of the third toss. So for the first toss, you could have a head or a tail. In the second toss now, so you have a second toss if you had a head first, and then you have the results if you had a tail first. All right, and so on and so forth. What else? Along a path, for example, here, 2, 3, those are independent events. Those are independent events. And here, these events are mutually exclusive. So if I want to determine one outcome or another, I would add the probability of the outcomes. And if I want to determine one particular outcome, I would multiply the probability of all of the combined events that lead up to that outcome. With that in mind, I want you guys to attempt example 14. I want you to attempt example 14. In example 14, we are told that a family has 2 children. We're to draw a tree diagram showing the possible outcome, assuming that the probability of a boy is 0.5 and the probability of a girl is 0.5. All right, so example 14 again. A family has 2 children. We're to draw a tree diagram showing the possible outcome, assuming the probability of a boy is 0.5 and the probability of a girl is 0.5. All right, so let's talk about the first child. For the first child, now you could have either have a boy, and the probability of a boy is a half, or you could have a girl, and the probability of a girl is a half. Now, for the second child, now we could have a boy or a girl. So this is boy, the probability of a boy is a half, or you could have a girl, and the probability of a girl is a half. Now, if the first child was a girl, now the second child, you could have a boy, the probability is a half, and or you could have a girl, the probability being a half. So this is what the tree diagram would look. This would be BB, which would mean the first child is a boy, and the second child is a boy. This is BG. The first child is a boy, the second child is a girl. GB and GG. So this is what the tree diagram would look like for a family that has 2 children, and the probability of a boy is 0.5, and the probability of a girl is 0.5. Zoom a little. All right, so if we want now, let us say, to find the probability of BB, probability of 2 boys would be a half times a half, which would be a quarter. As a matter of fact, the probability of every outcome here is, this is what? The probability of BG, the probability is also a quarter. Now, if someone asks you for the probability of, let us say, BB or GG, this would be the probability that both children would have the same sex, the probability that both children have the same sex. It would be a quarter plus a quarter, which is what? A half. So there's a 50% chance that both children will have the same sex. There is a 25% chance of getting a boy and a girl, or a girl and a boy. A 50% chance of both children having the same sex. All right. So those are some of the things that we could gather from this if we were asked.